Hey everybody, sorry, I realized that I skipped the last page of the notes. Sorry about that. We still have all these on page 59 to solve, so let's go through those. Okay, so let's say we have Q is equal to 1/2 P. So the 1/2 of the P is going to get multiplied by this quantity T, and then when we put the number down there, this is a subscript, so we usually read this as T sub 1 and T sub 2. So these are usually with T's, they denote times. So we're trying to say this is an unknown variable of time, and this is another unknown variable of time, and they're not equal to each other. And they want us to solve for T sub 2. Alright, so first we have to identify where T sub 2 is. It's inside of here. So since this is all multiplication, okay, this 1/2 times P times this entire quantity, and what we want is T sub 2 and it's in the quantity, let's isolate the quantity first. And again, we don't like fractions, so let's get rid of them, and I can multiply this whole thing by 2 over 1, and this side by 2. So this will be 2Q is equal to, now the 2's will cancel, and just P times the quantity, T sub 1 plus T sub 2. Now we need to, now P is being multiplied by this quantity, so I can divide through by P. So on this side, we'll have 2Q over P, and on this side, the P's will cancel, leaving just the T1 plus T2. Now the only thing that's happening to T2 is that it's being added by T1, so I could just subtract T1 from both sides. So this will cancel, and we'll be left with T2 is equal to 2Q over P minus T1. Now, we could get a common denominator here if we wanted to. We could say this is over 1, so we can multiply by P. Then on the left-hand side, everything would be over P. This first one is just 2Q, and then minus PT1. So either one of these is acceptable. In the next example, we have 1 over P plus 1 over Q is equal to 1 over T, and they want us to solve for Q. And again, we have the problem that Q is in the denominator. So let's use our method anytime we have fractions of getting a common denominator. Right? In this case, our least common denominator is just going to be multiplying everything together. P times Q times T. So in this one, I have the P. I have to multiply by the QT. In this one, I have the Q. I need to multiply by the PT. And in this one, we have the T, so we need to multiply by the PQ. Now we can write it as one great big fraction with the denominator of PQT. Here we have QT. Then we add to it PT, and that would be equal to PQ. Now that we have a common denominator, let's multiply through by that. So these will cancel, and we're simply left with up top the QT plus PT is equal to PQ. Okay, we're almost there. Our goal is to solve for q. Now here's a q and here's a q. Right. So we need to get these on the same side of the equation. So let's subtract pq from both sides. So now we would have qt plus pt minus pq equals 0. And this term doesn't have a q in it, so let's move it to the other side. So we have qt minus pq is equal to 0 minus pt. Well, that's just minus pt. Okay, so here's the trick. Now we have two q's, and we need a single one. We want it to say q equals something. So what we have to notice then is that I have two terms, and in these two terms, there's a common factor of a q. So if I factor that back out, then I'm just left with t minus p is equal to negative pt. So that is the trick there. Get all of your variables on the same side and then factor it out. Move the ones that don't have your variable that you're solving for to the other side. Now q is being multiplied by t minus p, so we will just subtract. Then these will cancel. And finally we have what we were looking for. Q is equal to negative pt over t minus p. Let's do the last two. These are like where we solve for y. Okay. So 5x minus 2y is equal to 10. Now the last time I subtracted 5x, and then I had to divide by, I think it was a negative 4y in the last example. Here's an alternative. So I don't have to divide by a negative. Let's add 2y to both sides. So on this side we'll have 5x. This will go to 0. And these aren't like terms, so they will stay the same. Now I can subtract the 10 from both sides. So 5x minus 10 is equal to 2y. And finally we can divide by 2. So over here we will just be left with y. The negative here, 2 goes into 10 5 times. And then here we could write this as 5 halves of x. Okay, let's do the last one. X over 2 minus y over 3 is equal to 4. Again, we have this minus y and we're solving for y. So let's move that over to this side and the 4 over here. So that would be x minus 2, or x over 2 minus 4 is equal to, now I had to add y over 3, so this is y over 3. Now our y term is positive, so that's a nicer thing for us to deal with. Okay. Getting a common denominator, which is going to be 6. Okay. Multiply by 6. Here by 2, here by 2, here by 3, here by 3. Okay. So this is over 6 is equal to over 6. We have 3 times x, which is 3x. Minus 6 times 4 is minus 24, is equal to 2y. Now again, we can multiply that through by that common denominator. So the 6's will cancel, leaving us just the numerator. 3x minus 24 is equal to this numerator, which is 2y. And now we're almost done. We're trying to solve for y, and y is being multiplied by 2, so we can just divide everything by 2. Then here the 2's will cancel, and we'll get y is equal to minus 2 goes into 24 12 times, and 3, we can rewrite this as 3 halves of x. Okay, now I think we've completed the entire lecture. And so with these, just keep in mind what you're solving for and what you can and cannot do by the rules of algebra. Email me if you have a question.